All right, so today we are going to look at section 5.1. This is domain and range of functions. Okay, so we're going to define first what a function even is. So a function is a relationship that pairs each input, which are the x values, with exactly one output, y values. Notice, and I didn't put this in the notes, but this is something to notice. This is not saying the other way around. This is not saying each output is paired with an input. This is just saying each input is paired with an output. And as we go through this lesson, you'll kind of see what I mean by that. Okay? So let's go ahead and define what domain and range are. And we'll come back to this function thing here in a second. But for now, we're just writing down these definitions. And if you need to pause the video, you can pause the video anytime so you can take the time to write these down. So first off, domain is all of the possible x values within a function. Range is all the possible y values within a function. Okay, so you're just going to list out, if I ask you for the range, you're going to list out all the possible y values that our function can be. And then same with the domain. If I ask for the domain, you need to list out all of the possible x values. Okay, let's look at an example and we'll see how to tell if something's a function, and we'll figure out how to identify the domain and range, all within these examples. Okay, so A. So example A, I'm going to go ahead and say that this set of coordinates is a relationship, right? So if you have a set of coordinates that belong on the same graph, that's a relationship, okay? Doesn't matter if it's a function or not, it's still considered a relationship. It could be just like you can have a good relationship or a bad relationship, it's still a relationship, okay? So I went ahead and highlighted all of the x values in yellow and all of the y values in green to match up with what we're saying here, right? And in fact, I could even highlight these as well to show that these also correspond here. Why don't I go ahead and do that? So I'm going to take the domain. That's yellow for all the x values, okay? And then I'm going to take the range in green for all the y values, okay? This is all related. All right, let's move on to asking the question, is this a function though? Is this a function? So let's dissect it and see if it meets the criteria meets the criteria set up in what a function is. So here I went ahead and listed all the inputs, all the possible x values, right? And then I went ahead and put them above all the outputs that they belong to, right? And now we have to ask, is each input paired with exactly one output? So if we look here, we can see that every single input has one output, which means the answer is yes, which means this is a function, right? And if I'm going to list out the domain and range, I kind of already did that with the inputs and outputs, but now I'm just calling them domain and range. And something I want you to keep in mind for this next example is that if a number shows up more than once, you're not going to need to list it more than once, right? You're only going to need to list it one time. Let me show you what I mean in example B. So example B shows a bunch of points, right? We have all of our x and y values here. Something I want you to notice is we have one repeat value within the x values, which is 8. So when I give you my domain, I'm going to point out you do not need to include the repeat. So I'm just going to write down 1, 8, right? I'm not going to write down 6, 7, 8, 8, right? It's going to just be 6, 7, 8. Those are all, because remember, we're just listing all of the possible x values. I don't need to tell you twice that 8 can be an answer to this, right? And then for the range, I'm going to list everything in order. You don't have to list things in order, but I just like to. And and I just list out all the possible y values. They don't have to match up here. I just chose to write it in order, okay? Now when I go to write the inputs here, which you don't have to do this every time, if you're able to identify just by looking at this if this is a function or not, then you're good to go. However, I'm going to go ahead and write out all the possible inputs and then all the possible outputs to show you what an example of a non-function looks like. So notice that 6 is paired with 10, 7 is paired with 8, and 8 is actually paired with 6 and 5. Since it's paired with 2 outputs, it means it does not meet our criteria of being paired with exactly 1. So I would have to say for this one, not a function, right? Now, if this was flipped, if this was reversed, and we had 4 inputs and 3 outputs, and one of our outputs was actually paired up with 2 of our inputs, this would still be a function. This only works if one of our inputs, if at least one of our inputs, is paired with 2 or more outputs, or maybe it's paired with no outputs, right? Which I don't even know what that would look like. So go ahead, pause this video, and I want you to do page 204, numbers 1 and 2, okay? And then I also want you to add to this, so what the directions say is they want you to say what the domain and range are, but I also want you to state if this is a function or not. And I want you to kind of have a reasoning why you believe it's a function or don't believe it's a function, okay? So pause the video and then come back here. All right, so let's go ahead and look at this. So I'm going to go ahead and just show the whole problem here and put it in frame. Okay, so if I'm looking at this, number 1, I've got all 4 points right here. Notice that they all go along the same line. So you're going to have a lot of repeat values in the range, right? So when I go to write down the domain, I'm just writing down every possible x value. And there's only 4. Either my answer can be x is equal to -3, or x is equal to -1, or x is equal to 1, or x is equal to 3. So I write down all 4 of those possibilities. Then next, I'm going to write down all the possible y values. But here you can see there's only one possible y value, and that's -3. This never leaves this line. So for the range, remember, we don't need to write down any repeats. I'm going to write down just -3 as my y value, or as my range, right? And I'm going to show all the things that are paired with this -3. Now remember what we talked about before. Something can still be a function if one y value is paired with multiple x values. We just cannot have, like this 3 cannot have 2 lines coming off of it. It cannot go to -3 and maybe the number 7 or something, right? Since there's only one line coming from each individual input value, doesn't matter if it repeats on the output, this is still technically a function, right? If this was flipped though, if our domain was just one value and it had 4 outputs, we would say no. But since it's like this, we say yes, okay? So notice that we have to follow the rule exactly as written, right? Okay, so each input has one output, that's true. -3 has -3, -1 has -3, 1 has -3, and 3 has -3. So that still follows our rule, okay? All right, next up, we've got number 2. Number 2 has the same exact case. We have a bunch of individual domain values. So we have -2, -1, 0, 1, and 2. Those are all the possible x values here that we have on the graph. But then when I look at the y values, I see that I only have 3 values, right? So we either have 0, or we have -2, or sorry, not -2, or we have 2, or we have 4, right? And we have 2 values on each of these points here. If I were to pair all these up and I were to show all the lines coming off of these, I would only have one line coming from each input value. There's not a point where I have 0 going to 2 different values down here, right? So the answer here is yes, this is a function because each input has exactly one output, okay? That's how it works. All right, so I'll see you in the next video for part 2.